This video is meant to show you how to answer questions involving magnification and magnification calculations. The example that we're looking at here is one that's taken from your notes pack. In this example, you have been asked to calculate the actual length of this cell between points P and Q, and you're told the information that the cell has been magnified by 1,000 times. So this cell, or this image, is 1,000 times bigger than the cell is in real life. In any question like this, the first step you should take is to write out your equation for calculating magnification. So here is our equation, and it's stating that magnification is equal to the measured size divided by the actual size. Now you'll see that in this question we've been asked to calculate actual size rather than magnification. So the first step that we're going to need to take is to rearrange that equation. Now we can rearrange it in this way. If we bring the actual size round to the left hand side of the equation, we can replace that with magnification on the bottom of the equation there. So we work out that actual size is equal to measured size divided by magnification. The next step in this equation is going to be to determine our measured size. We're trying to work out actual size. We've been told magnification, so our missing variable here is our measured size, which is how big the image actually is between points P and Q. At this point, we're going to need a ruler. If I'm going to measure this correctly, I'll need to put the ruler up to points P and Q, and you can see there that between points P and Q we've got around 5 centimeters. Now I'm going to suggest that you don't measure things in centimeters during your A-level biology course, because that makes converting units more difficult. I'd rather you measured in millimeters, which are the smaller notches on the ruler, so our measurement here would be 50 millimeters. So we know that our measured size is 50 millimeters. We know that our magnification is times by 1,000. We're nearly at the point where we can answer the question. The problem that we've got is that, as you can see, we're looking for an answer in micrometers, but our measurement here is in millimeters. Now we can't do a calculation successfully here unless we have got units that are consistent throughout. So what we're going to have to do here is we're going to have to convert millimeters into micrometers. Fortunately, your notes booklet gives you some guidance on this. You can see from the diagram below, which is in your notes booklets, that if I want to convert from millimeters to micrometers, millimeters are on the left of my diagram, micrometers are in the middle there, I need to times by 1,000. So I need to multiply by 1,000 to convert from 50 millimeters to micrometers. Here's the final sum that I'm left with then. I'm left with the calculation that 50,000 divided by 1,000 is equal to 50. So my final answer here is going to be 50 micrometers. I should always do a final check here just to make sure that my answer is plausible. In this case, 50 micrometers is a very sensible size for a cell. The majority of animal cells, and this is an animal cell we're looking at here, as you can tell by the nucleus and the fact that it's got villi here, 50 micrometers is a fairly typical size for the length of an animal cell. So that's how to do a fairly simple calculation involving magnification. The next video will show you what to do in a slightly different kind of calculation, where instead of being asked for the actual size, you're asked for the magnification of the image.